In the last class, we discussed the graphical method of solving a pair of linear equations. Okay, today we shall be discussing the algebraic methods of solving a pair of linear equations. Okay, let us move on to the algebraic methods. Which are the algebraic methods? So there are algebraic methods. So they are substitution method, then we have the elimination method, then we have the method of cross multiplication. Method. Okay, so now we shall start with the method of substitution. Okay, so what is there in method of substitution and how it is done? So suppose if you are given a pair of equations, then you consider any one of the equations and convert it in terms of the other variable. Express one variable in terms of the other variable and substitute that variable in the other equation. Okay, so let us take some examples and understand how to solve this type of problems in using substitution method. Okay, so now for substitution method. Okay, let us take an example, a pair of linear equation, and try to understand how to solve this pair using the method of substitution. Okay, so let us take the example. Say let us take 7x minus 15y equal to 3. This is one equation. So let me take 2, and x plus 2y equal to 3. X plus 2y equal to 3. Okay, so this is equation number 1, this is equation number 1, this is equation number 2. Okay, so now I will consider any one of the equations which appear more simple, and it happens to be equation number 2. Okay, so I will consider equation number 2. So from x plus 2y equal to 3, I get, see, I will express either x or y in terms of the other variable. If I can express x equal to something or y equal to something form. So let me first of all consider, say since this is y, 2y is equal to 3 minus x. Okay, 2y is equal to 3 minus x. That is, y will be equal to 3 minus x by 2. So this is what we are going to substitute into. So this is derived from equation 2. This is equation number 2. Okay, this is equation number 2. So from equation number 2, I got the value of y, or the expression of y in terms of x. Now this is to be substituted into equation number 1. I have to place this value inside this. Instead of y, I will be replacing it by 3 minus x by 2. Let us see. Now we will consider the first equation. This is 7x minus 15y equal to 2. This is 7x minus 15y. Instead of y, I cannot put y, but now I have to put, instead of y, I will place 3 minus x by 2, and that is equal to 2. Okay, now we need to adjust this thing. How to remove? So before, let us simplify first of all. So this is 7x minus 15 3s are minus 15 into 3, 15 3 is 45, minus plus, so let minus be there. So this is 15 3s are 45 minus 15 into x is 15x by 2. This bracket is as it is, minus is also there. Okay, now that is equal to 2. Now multiply both sides of the equation by 2. Multiply both sides of the equation by 2, so that is the LCM of the denominator. So multiplying by 2, what we get? We get the 7 into 2 is 14x minus say 45 minus 15x. This is still in bracket. That 2 gets cancelled. Okay, so let me put it here and show. This is 2. I have multiplied 2 here, I have multiplied 2 here, and that is 4 here now. Okay, these 2 will get cancelled, and let me move further. So 14x, so this is 14x minus 45 minus into minus is plus 15x, and that is equal to 4. Okay, so 14 plus 15 is 29, 29x, that is equal to 45 plus 4. So x will be equal to 49 by 29. X is equal to 49 by 29. Okay, now we shall substitute this value of x into any one of the equations. Okay, let us substitute this value of x in any one of the equations. So which equation? I feel this would be simple. So placing or putting value of x is equal to 49 by 29 in equation 2. Okay, so what is equation 2? Write it down again. X plus 2y equal to 3. Okay, now instead of x we will be placing 49 by 29 plus 2y equal to 3. Okay, now we will take 49 by 29 on the other side. So y is equal to, 2y is equal to 3 minus 49 by 29. This y becomes 19 by 29. 19 by 29. This will give you 19 by 29. Okay, so final solution is for x equal to 49 by 29 and y is equal to 19 by 29. Now we shall start exercise 3.3. Now we shall start exercise 3.3, where we shall do more problems to learn how to apply substitution method in a perfect way. Okay, let us start. So we will be doing exercise 3.3. So let us write down the question. The first question says solve by, this is solve by substitution method. Okay, we are learning how to solve the problems by using substitution method. Okay, so let us start. So this is x plus y equal to 14 and we have x minus y equal to 4. So how can we do this? This is, we will be converting any one of the variables in terms of the other variable. So let me take the second equation. This is the first equation and this is the second equation. Okay, so now from the second equation, let me consider the second equation as say x minus y equal to 4. This is from equation number 2. What I have this. So this will give y equal to x minus 4. Y equal to x minus 4. Okay, so I will be using this substitution into the first equation. So I will be putting this value of y, this expression, into equation number 1. So now consider equation number 1. Equation number 1 is x plus y equal to 14. Now instead of y we will be putting this expression. So replacing y in terms of x. x minus 4. So y is x minus 4, that is equal to 14. X plus x will give you 2x, and this is 14. Minus 4 goes that side, it becomes 14 plus 4. So 2x equal to 18, and x becomes equal to 9. Okay, 2 into 9 is 18. 2 into 9 is 18. Okay, so you have got x. Now we shall be substituting this value of x. So substituting x equal to 9 in this expression. This is the expression which we have converted already into a simple form, or y equal to something form, y equal to y in terms of x. So we will be writing that y is equal to x minus 4. Okay, so y is equal to x minus 4, and we will be putting x equal to 9 in this place. So 9 minus 4 is 5. So I get y equal to 5. Okay, so therefore the solution of the given equation, the given pair of equations is x comma y. X is 9 comma 5. Okay, this is an ordered pair. It is a point of intersection between the two lines. Now let us move on to the next example. So the next example is s minus t equal to 3, and the second equation of this pair is s by 3 plus t by 2 equal to 6. Okay, so now I shall be converting any one variable into the other variable. Okay, so in this case, let us see, I can express s in form of t or t in form of s. So I will be taking t in form of s. So from equation number 1, this is equation number 1 and this is equation number 2. Okay, so now I will be taking t is equal to, from equation number 1, I can get, from equation number 1 I will get t equal to s minus 3. Now I shall be substituting this value into the given situation. Okay, so this is the second equation. Now putting this value, so putting t is equal to s minus 3, in equation number 2. So what is equation number 2? Equation number 2 says that it is s by 3 plus t by 2 equal to 6. So what is t? T is s minus 3. So I will be putting t as s minus 3. So s by 3 plus, what is t? T is s minus 3 by 2, and that is equal to 6. Now let me multiply the whole equation by 6 so that I can get the denominator portions away. So multiplying by 6 on all the three terms. So I will be multiplying 6 here, because 6 is the LCM of this term, 6 here, and I will be multiplying 6 with this 6 also. So now what I get here is, so 3 into 2 will go as, so 2s plus 2 into 3 is 6 into s minus 3 equal to 36. Okay, now let us expand further. 2s plus 3s minus 3 into 3 is 9, and that is equal to 36. Okay, 3s plus 2s will give you 5s. Minus 9 goes that side, is equal to 36 plus 9. So 5s equal to 36 plus 9 is 45. So s equal to 45 by 5. S is equal to 45 by 5, that is 9. S becomes 9. Value of S is 9. We can now substitute S equal to 9 in this equation. So substituting S equal to 9 in T equal to S minus 3 in this expression. Okay, we shall get the value of T. So what is T? T is equal to, instead of S we will be putting 9. 9 minus 3, and that is 9 minus 3 is 6. Okay, so T equal to 6. So therefore the solution is here, which is the first variable, S comma T. So first one is taken as S comma T equal to, we will write this here. In case of X and Y we may not mention because that is a standard and general format, but when S and T comes we really do not know which variable to take first and which one as the second. So we will mention which order we have taken, and we will say that it is S comma T. That is, we have already taken S equal to 9 here and T is equal to 6 here. So S equal to 9 and this is 6. So this is the point or the solution, or it is a point where the lines intersect each other. Okay. Now let us take the third example. The third example. Here it is given that 3x minus y equal to 3. The second equation is 9x minus 3y equal to 9. See, as I have described earlier, we know that we need to observe the equations first before solving. Just by observation, it is very clear that the second equation can be obtained from the first equation by multiplying any one number, multiplying 3 to the first equation. If that happens, we say that the lines are coincident and it will have infinitely many solutions. So actually we may not be able to solve them by using substitution because there are infinitely many points possible, so you cannot get a unique solution. Okay, so here in this case we shall observe that, see, a1 by a2 is 3 by 9, which comes out to, say, it is 3 1s are 3, 3 3s are 9. Okay, and what is b1 by b2? Coefficients, the ratio of coefficients of y is equal to, this is minus 1 by minus 3, which comes out to 1 by 3. Also what is c1 by c2? When they are equal, you need to check whether the constants are also, the ratio of the constants are also equal to the first two ratio or not. So c1 by c2 is 3 by 9, which comes out to be 1 by 3 again. So it is here it is clear that a1 by a2 is equal to b1 by b2 equal to c1 by c2. So this happens if all the three ratios are equal. We say that the lines are coincident. Therefore the lines are coincident lines. Hence, so therefore they have infinite solutions. Okay, they have infinite solutions. So we will just mention this and keep it there because it is not practically possible to find out all the solutions. We will just mention that there are infinitely many solutions and that is over. So we cannot actually now use substitution in this case. Substitutions and method will be used only in case of those problems which can be solved for unique solutions. Okay. Now let us do the next problem, that is the fourth problem of our textbook. So the fourth problem is as follows. So question number 4. So in this case it is 0.25 2x plus 0.3y equal to 1.3, the first equation. Okay, this is the first equation. Now the second equation is 0.4x plus 0.5y equal to 2.3. This will be the second equation. Okay, now we have to find out the values of x and y. We need to solve them. Okay, so first we will simplify these things by removing the decimals, and it is very simple to remove the decimals. Just by multiplying 10 throughout both the equations, we will remove the decimals. Okay, so the equations can be transformed. This set or this pair of equations can be transformed to, by multiplying 10 with the first equation, you get 2x plus 3y equal to 13 and 4x plus 5y equal to 23. Okay, now from this equation, this is equation say 3 and this is equation number 4. Okay, we have transformed these two equations, given equations, into a different form. Now what I am going to do, I will be taking y equal to something from this equation number 3. So consider from equation 3, what do I get? I get 3y equal to 13 minus 2x. Okay, so y becomes 13 minus 2x by 3. Okay, now it can be substituted into equation number 4. Okay, so this is, now we will take equation number, putting the value, substituting value of y into equation number 4, substituting y in equation number 4. What we get? This is 4x plus 5y equal to 23. Now y is replaced by 13 minus 2x by 3. So it becomes 4x plus 5 into, this is 13 minus 2x by 3, that is equal to 23. Now to simplify this and to get rid of the denominator 3, we will be multiplying the equation throughout by 3. So this becomes 4 into 3 is 12x plus 5 into 13 minus 2x, as it is 3 will get cancelled when we multiply 3, and this becomes 23 into 3. 23 into 3 is 69. Okay, how did we get? Multiplying by 3, we get this expression. Now let us further simplify this expression. So this is 12x plus 13 5s are 65 minus 5 2s are 10x, and that is equal to 69. Okay, so 12x minus 10x will give you 2x, and that is equal to 69 minus 65. This 65 goes that side, so it becomes 69 minus 65. 69 minus 65 is 4 and x, 2x present here. So x becomes 2. So x is obtained. So we have the value of x as 2. Now we will take any one of the equations. Which one? We will be taking this expression. So 2x plus 3y equal to 13. Now we will put the value of x equal to 2 in equation number 3. So we will write down the equation 3 first. So it is 2x plus 3y equal to 13, and now instead of x we will put 2 and we will get the value of y. So it is 2 into 2 plus 3y equal to 13, which becomes say this is 2 into 2 is 4 plus 3y is 3y, and that is equal to 13. Now 3y equal to 13 minus 4. So we have 3y equal to 13 minus 4, which becomes 9. So this is 9. So y, and here we have 3. So y is equal to 9 by 3, and that is equal to 3. Okay. So now what do we have? We have both the values x and y equal to 3. So therefore the solution of the given expression is x equal to 2 and y equal to 3. So therefore x comma y is equal to 2 comma 3. I hope you have understood this problem. Let us now move on to the next problem. So the next problem is question number 5, that is given as root 2 into x plus root 3 into y equal to 0, and we have root 3 into x plus root of 8 into y equal to 0. Okay. Now I can take any one of the equations first of all. So this is equation number 1 and this is equation number 2. So clearly these two lines do not have the constant parts. So a line which do not have the constant term, a straight line ax plus by plus c equal to 0, a straight line which is represented by ax plus by plus c equal to 0, if it has c equal to 0, it will pass through the origin. Okay, so this happens here in both the equations. Here the constant terms in both the equations are invisible, means they are not present or they are 0. So it means that both the lines pass through the origin, and the origin itself will be the solution, okay, of both the equations. They are intersecting each other at the origin. That is clear. Also we may observe that this is root 2 by root 3 and this is root 3 by root 8, which both of them are not equal. So they have a unique solution and they intersect each other at the origin, that is 0 comma 0. Okay. Now let us proceed with the substitution method. We have observed that the solution is 0 comma 0. Now let us go with the substitution method. Okay. So now let us consider the first equation and convert it into y equal to something of x form. Okay. So this is root from the first equation. The first equation from equation 1. From equation 1, what we get is root 3y is equal to root 3y equal to root 3y equal to root 2x. So y can be expressed as root 2x by root of 3. Okay. Now this is what we are going to substitute into the second equation. So second equation is, so now from equation 2, we have root 3x plus root 3 root 8 y equal to 0. Correct. So root 3 x plus root 8 as it is, and instead of y we will be taking root 2 into x by root of 3, and that will be equal to 0. Okay. So now let us multiply the whole equation by root 3 to get rid of the denominator root 3. Okay. So when I multiply it by root 3, when I multiply by root of 3, by multiplying this by root of 3, what I get is root 3 into root 3 will become 3x plus root 8 into root 2. This is root of 8 into root of 2 into x, and that is equal to 0. Okay. That is equal to 0. What is root 8 into root 2? Root 8 into root 2, see, let me write it here. So this is root of 8 into root of 2. That can be written as square root of 8 into 2. That is square root of 16. And that is equal to 4. So I can write 4 instead of this. So this is 3x plus root 8 into square root of 8 into square root of 2 is equal to 4, and x, that is equal to 0. So 3x plus 4x is equal to 0. So what can I get? I can get 3x plus 4x, and that is 7x. So we get 7x equal to 0, or x equal to 0 by 7, which is again equal to 0. Okay, so x equal to 0. As we have described, it is the origin. So x should be 0 and y should also be 0. Now let us see. Let me take the first equation, or let me take this itself. Now y is equal to root 2x by root of 3. From this equation we have y, the value of y. Let us put the value of x into this. So y is equal to square root 2 into 0 by square root of 3. 0 into anything becomes 0. So y also becomes 0. So finally we have the solution. The solution of the given set of equations is x comma y is equal to 0 comma 0. Okay, they intersect each other at the origin. Now let us move on to the next example. Question number 6. The sixth problem, that is 3x by 2 minus 5y by 3, and that is equal to minus 2. Okay, and we have here as x by 3 plus y by 2 equal to 13 by 6. Say, look, we need to simplify these equations and remove the denominators as much as possible. So we will do it parallelly. So first of all, let us see. The LCM here is 6. So I will multiply by 6 throughout. So when I multiply by 6, what do I get? When I multiply by 6, what do I get? This is one set. Okay, so the set becomes, when I multiply by 6, it becomes 6. 6 into 3x by 2 plus 6 into, minus 6 into 5y by 3, and that is equal to minus 2 into 6. Okay, and 6 into x by 3 plus 6 into y by 2 equal to 6 into 13 by 6. Okay, now we can cancel these numbers by taking, say this is 2 into 3 is 6, 3 into 2 is 6. Okay, 6 into 2, 2 into 3. Okay, so what do we get? And here the 6 gets cancelled. So the equations, this is one set. So you need to write them in sets. Okay, 3 is a 9, x minus 5 into 2 is 10y, and that is equal to 6 into 2 is 12, negative. So then 2x, the second equation becomes 2x plus 3y equal to 13. Okay, so now this is the simplified form of what we already have. Now let us solve these two equations. We will, instead of naming them 1 and 2, we will name this as 1 and this as 2. These are the same set of equations but a transformed one. Okay, so now 9 into 13 is 117. Okay, now see 20y plus 27y is 47y, and that is equal to 117 plus 24, that is equal to 7 1. Okay, so 2 3 4 and 141. 47y is equal to 141 by 4 is equal to 141. So we have y equal to 141 by 47, and this becomes You can cancel this into 3. So you get y equal to 3. Now placing y equal to 3 in this expression. So this is x equal to 10 into 3 minus 12 whole by 9. Okay. So this is 30 minus 12 by 9. So 30 minus 12 is 18. It should be 18. 18 by 9. And what is 18 by 9? 18 and 18 by 9 is 2. So x is equal to 2. So therefore the solution of the given equations is x comma y equal to 2 comma 3. This is 2 first and then 3 equal to 2 comma 3. This is your final answer. Okay.